Okay, Trig kids, we are skipping section 10.4, so we went straight from 10.3 to 10.5. This is the section on vectors, which I really like teaching. I wish I could teach this in front of the whole class in person because I really just like it. But some of you guys have probably had vectors before if you are in physics. You've probably talked about vectors already this year, but here is kind of how vectors work, okay? So vectors. A vector is kind of like a ray where it has a starting point, which they call the initial point. I'm going to label him as I, or INT, or I don't know, INT for initial, okay? And they call that initial point P, okay? And then you have your terminal point, which is Q, and he kind of like basically is listed as an arrow, so you know, even though he starts here and stops here, you know which direction he's going. So he's going from P to Q, initial side, terminal side, okay? And then vectors, the way that they are labeled with boldface letters. So like U, V, and W are a lot of times with the letters that they'll use for vectors. U to make a boldface U, they'll do that where they'll like add like a bold side onto the right. V will be made like that. Well, they add a bold side onto the right, and then W, a boldface letter onto that side, so it kind of looks three-dimensional. If you just call them UVW, I'm not going to get particular about writing them as bold, but that's just kind of the notation that we use, okay? All right, so when we talk about equivalent vectors, vectors are like basically line segments that are out in space, and two vectors are equivalent if they have the same direction. So like they're both going the same direction, and they have what's called the same magnitude or the same length. Okay, magnitude, another word for magnitude is length. So you notice these vectors U and V, they're both going kind of toward the top right direction, and they are parallel to each other. That can help you determine directions. So if they are parallel, they're going the same direction, and they have just about the same length. If I would get a ruler out and measure those, I bet they would be about the same length, okay? So these two, check out, they are equivalent. Okay, those two are equivalent. Now this one, even though they have the same magnitude, the same length, they are going opposite directions because one of them is going this way, one of them is going this way. So those two are not going to be equivalent to each other, okay? These two are going the same direction because they're both going down and to the right, but they do not have the same length. Their magnitude is different. So these are not equivalent, and these have neither of them. They're not the same length, and they're not going the same direction. So this one's obviously not equivalent, okay? So you can kind of see scenarios of those. The only one that is equivalent is this one over here, okay? Now I'm going to go ahead and give you an example on another sheet of paper where we're adding vectors together, because that's what we're going to start doing in like example 1, example 2. But I'll show you kind of what that looks like visually. So you could probably write it off to the side over here if you wanted to do this, but I'm going to draw kind of big, so I'm going to do a separate sheet of paper. So I'm going to do, let's call this vector U. Okay, so there's my vector U, okay? And then I'm going to say vector V is like this guy. This is going to be my vector V. Okay, so here's my second one. Okay, and if I wanted to do this scenario where I'm taking U and I'm adding V to him, okay, what I'm going to do is I'm going to start by drawing U, and I'm going to do my best. If you need a ruler, you can measure that length there, but I'm going to try to draw him as best I can. He's about, oh shoot, I didn't want to do that, blah, 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 blah. Let me go down over here because I need some room. There is about what U is, okay? So I kind of did a decent job redrawing him. I'm gonna draw him as a U down here, okay? And then what I would do, so this is my starting point, this is my ending point of U, okay? If I'm adding V to that, I want to go start to end and start to end, okay? So what I'm going to do is where I ended my first vector is U, where I ended him, I'm going to begin drawing my V. So I'm going to take this V and I'm going to like slap him down right here, okay? And pray that they both kind of look the same. That's about what V looks like. Sure, there's my V vector, okay? Adding those together, that's about the same magnitude and direction, so same length and same direction there, okay? So I've taken u and I've added v to him, okay? I've taken the start end and then the start end of v, okay? And really the vector u plus v is going to be connecting those two together from here to here. This is really the vector u plus v, okay? That's what he will look like, okay? So when you're adding vectors together, you just start with your first vector, where that one ends, you put the other vector on, and just kind of be as close as possible. Now, what does it look like if you would do, let's say, u minus v instead? Okay, so I'm going to start with u again. About that long is how long u is. Okay, so taking that same guy from up here, kind of trying to draw the same length, same direction as best you can. And then what I would do is, since I'm wanting to subtract v, okay, v went kind of to the top right, okay? So basically what I'm going to do is I'm going to start here where I ended the u, and instead of going up this direction, right, v, if you think about him in terms of being like plus a negative v would kind of go the same length, but in the backwards direction, right? Instead of him starting here and going up, he's going to start here and he's going to go down, okay? So this is negative v, basically, and then your u minus v would be here. So this would be u minus v. Okay, so we're taking one length of u and we're subtracting a length of v. Okay, I'll do one more example and then we'll go back to the notes. So let's say I have u plus 2v. Okay, u plus 2v. All right, so I'm going to start with u again. Do my best to draw this. You guys might already kind of know, maybe have a guess as to what this is going to look like, but here's u. Okay, kind of trying to draw him same direction, same magnitude, everything. Okay, and then v, I'm going to end where I'm at here. It's a positive v, so I'm going to go this direction. There's what one v is. Okay, but then I'm going to start here and I'm going to go a second v. Okay, so here is v, and here is another v. Okay, so when I'm adding u plus 2v, that will be from start to finish this vector right here. Okay, this will be u plus 2v, and that's what he will look like. Okay, start here, end there. That will take me exactly where he's trying to go. So the way that this works, and what we'll start getting into when we do applications with vectors, which I think is in 10.6, which won't be for a couple days from now, because this section is going to be 2 videos long. But what's happening is basically what we'll start doing in story problems is, like, let's say you have the scenario where you're throwing a ball into the air at a force of, I don't know, a certain force, or you're kicking the ball, and then the wind is coming back at you in this direction, right? Okay, at a particular force. What's going to happen to the ball is the ball's going to go like straight up, basically, or it's probably going to curve as the wind is carrying it. But what will happen is it will end up probably right about here, according to how forceful the wind is, this being the wind, and how forceful your kick is, okay? And we'll just kind of determine where that ball will end up, okay? So that's kind of how vectors come into play. I really like dealing with vectors just because, this is basically what people flying airplanes have to deal with all the time. They have to deal with air resistance and where the plane's going to end up. So, sometimes if they're trying to travel directly north and the wind is going or coming from the east, they might have to travel into the wind so that they get exactly in the north direction, okay? So let's talk about vectors. We'll do a couple of these examples and then we'll stop. Talking about equivalent vectors, they have example 1. They're starting P at 1, 2. Okay, so I'm going to draw a little coordinate plane over here. At 1, 2. 1, 2 is where P is going to start with, and he's going to end at 5, 4. So 1, 2, 3, 4, 5, 4 is going to be this guy right here. This is PQ. Okay, so there he is, right? PQ. And then O is starting at 0, 0, and he's going to the point 4, 2. Okay, So that's where this guy is, okay? And they want us to show that those two are equivalent vectors. There's a typo here. This says QR, but it should say OR. So it wants me to show that those are equivalent vectors. Well, basically, I have to determine whether the same length and the same direction, okay? So what I can do is I can just look at from here to here. From 1 to 5, he is going to the right 4 units, right? And then from 2 to 4, he is going up 2 units, right? From 2 to 4, up 2 units, okay? So let's look at this one. From 0, 0 to 4, 0, he is going to the right 4, and he's also going up 2 units, okay? And as long as that's happening, it doesn't matter where they're starting and ending, as long as they're going the same direction for the same amount, they both will be equivalent vectors. So we have just showed that they are both equivalent, okay? Now what they're going to do is they have you write the component form of a vector, okay? So component form will be written as, they're wanting us to do, if this is starting, this is ending, component form of PQ will look like this. They will be in like triangle brackets, like this guy, okay? Triangle brackets. And basically this is going to tell you where you're going. So this is left and right, and this is going to be up and down, okay? Component form of both of these two vectors would be, if we're going to the right 4, it would be 4, comma, 2. That means you're going to the right 4 and you're going up 2. That's what component form would look like. So from here to here, we have to determine, okay, which direction are we going? So from -2 to 4, we are going to the right 6. So I'm going to write that as a positive 6, okay? If you need to do the computation, it would be x2 minus x1, okay? So this really is like 4 minus a -2, or 4 plus 2, which is 6, okay? And then going from 6 all the way up here at 6 to a -3 down here, we are subtracting 9, right? 6 to -3 is -9. That means we're going down a 9, okay? Or if you need to do the math, you can do -3 minus 6, which gives you a -9. This is going to be your component form, 6, -9. So that means I'm going to the right 6, but I'm going down 9 for my vector, okay? And then the magnitude. So this is the component form. Find the components. That's the components, PQ. And then they want to know the magnitude. They want to know how large this thing is, okay? So if my vector is going to the right 6, but down 9, what's going to happen is he's going to look like this. He's going to the right 6, but he's going down 9, right? Something like that. That's what's happening, okay? If I want to find the length of this, you can kind of think about it as a right triangle. And you can just do like a squared plus b squared equals c squared, okay? And where a is going to be 6, b really is -9. That negative isn't going to really matter so much because when you square it, it's going to turn that negative positive. But then you're trying to find c squared. If I'm just trying to find c, I would take the square root of that, okay? So it would be the square root, I'll write that nicer, 6 squared plus -9 squared, and that will give me my c. Okay, so as soon as you have it in component form, it makes it really easy to find the length. You just slap those into kind of the Pythagorean theorem, and you solve for him. So 6 squared is 36, 9 squared is 81, and I take the square root of that, which is going to be, oh boy, 117, the square root of 117, and you can just leave him as the square root of 117, okay? So this is going to be your magnitude. This is going to be your component form, okay? Magnitude is also written up here as a squared plus b squared and the square root of that as soon as you have your component form like this, and that we kind of just talked about that, okay? Your component form is in your triangular brackets, I guess, okay? All right, so let's do one more example, and then we will stop, okay? So this is called scalar multiplication. That just means you're multiplying your vectors by a certain amount. So right here I have a vector v, they've called it. Before we called it PQ, so you can either call it PQ or you can give it a special name, v. But PQ or vector v is 3 and 1. That means 3 to the right and 1 up from some place. Maybe we're starting at 0, 0, maybe we're starting somewhere else. But we're going 3 to the right and 1 up, okay? What they want us to do is they want us to find the components of 3v, okay? Well, all we're doing is we're taking that and we're scaling it up by 3. Okay, so instead of going 3 to the right, we would end up going 9 to the right. And instead of going 1 up, we would go 3 up, because 9 times 3 is, or excuse me, 3 times 3 is 9, 1 times 3 is 3. That's what 3v would be, okay? Negative 2v would be just multiplying each one of these by negative 2, okay? So instead of going 3 to the right, I would actually go 6 to the left, because negative 2 times 3 is negative 6, and 1 times negative 2 is going to be negative 2, okay? And that's what he would look like, okay? All right, there is that. We could probably go ahead and do, I don't know how long this video is. Yeah, we'll stop there. We'll go ahead and stop there. Vector addition and vector subtraction is really super easy as well, but we'll save that for the next video, okay? You have a sheet that looks like this, which is vectors in the plane, and this will be your homework for section 10.5. You should be able to do 1 through 4, I think, at this point, and then also drawing these down here, 12 through 14, okay? 12 through 14, you're going to want to use kind of the drawings that I went through here to think about what those will look like, and the middle part we will talk about in the next video.